Good morning, student. Myself Satnam Singh, lecturer electrical engineering from Government Polytechnic College, Mohali, Madras. Today we will discuss the topic semiconductor material. In this lecture, we will discuss the introduction of different electrical materials, atomic theory, energy band, classification of material on the basis of energy band structure, crystal structure of semiconductor, semiconductor materials, germanium, silicon, intrinsic semiconductor, extrinsic semiconductor, n-type semiconductor and p-type semiconductor. So, different types of material which are used in electrical and electronics engineering are there are 4 types of material which we used in the field of electrical and electronics. First material is conducting material, second is semiconducting material, third is insulating, and fourth one is magnetic material. So, always remember in electrical and electronics engineering material 4 types of material are used: conducting, semiconducting, insulating and magnetic material. First is conducting material. Conducting materials are those materials in which the electric current can easily flow. In other words, we can say that material which offer very low resistance to electric current is called conducting material. Student, conducting material are those material which can conduct the electric current easily. Their resistivity is very low and conductivity is high. The resistivity of conducting material, the value of resistivity of conducting materials lies between 10 raised to power minus 8 to 10 raised to power minus 6 ohm meters. The most well known conducting materials are copper, aluminum, brass, bronze, etc. Atomic structure of conducting materials. Before discussing this topic, first of all we will discuss the atomic theory. The atomic theory states that all the matter, whether solid, liquid or gases, consist of minute particles called molecules, which can be further divided into atoms. The atom is defined as tiny discrete particle which is incapable of divisions. Those substances whose molecule consist of similar atoms are called element, and the material whose molecule consist of dissimilar atoms are called compound. So, atomic theory state that all the matters, whether it is solid, it is liquid or gases, they consist of minute particle called molecules. These molecules can further divided into atoms. Atoms are tiny particles which are which cannot be divided. So, all the materials, all the matters are made of atoms. Next is the Bohr's atomic theory. The Bohr's theory tell us that the atom of element consists of 2 main parts. First is nucleus, second is extranucleus. You can see in this diagram, this is the atomic structure of one material named as krypton. Student, if you see in this diagram, it consists of 2 main part. This red part is nucleus and these blue lines around the nucleus is called extranucleus. So, all the atoms consist of 2 main part, this red one nucleus and extranucleus. The center part of an atom is known as nucleus. It contains proton and neutrons. The nucleus holds the entire mass of an atom. The protons are the positive charge particles while the neutrons are chargeless particles. Therefore, the net charge on the nucleus remain positive. So, center part is called nucleus and it contains protons and neutrons. Protons are positive charge particles and neutrons are neutral particles. So, net charge on this nucleus is positive. And next is the outermost part of an atom around the nucleus is known as extranucleus. it contains electrons only. As the number of electron is equals to number of protons, so an atom is therefore electrically neutral. The number of electron in any orbit is given by 2n square, where n is the number of orbit from nucleus. So, to justify this, in if you see the diagram, it consists of 4 shell, first, second, third, fourth. The part around the nucleus is called extra nucleus, and it contains the electrons only. The blue circles you can see, these are the electrons. These electrons revolve around the nucleus in a particular shell. If you can see that the electrons are revolving around the nucleus in different orbit or shell. This blue line is representing the orbit, or you can say shell. So, if you see in the first shell, the number of electron is 2, in the second shell number of electron is 8, in the third orbit number of electron is 18, and in the last orbit number of electron is 8. So, student, the electrons in the extra nucleus part revolves around the nucleus in definite shell. The number of electron in any orbit is given by the formula 2n square, where n is the number orbit from the nucleus. You can see this is the first orbit from the nucleus. So, in this first orbit number of electron will be 2n square, n is 1. So, number of electron will be 2. In the first orbit 2n square, n is 1, 2 1 square is equal to 2. So, in the first orbit number of electron will be 2. In the second orbit, in this second orbit number of electron will be 8. So, the formula is 2n square. If we put the number of orbit, that is n is equal to 2 in this formula, then 2 to the square equals to 8. So, number of electron in second orbit is 8. In third orbit, if we put the n equals to 3, then the number of electrons in third orbit is 18. In the last orbit, the number of electron will be the remainder electron, that is 8. 2, 8, 10, 18, 10 plus 18 is 28, 28 plus 8 is 36. 36 is the atomic number of the krypton, and the 36 is the number of electron present in the atoms. So, this atomic structure follow this rule 2n square for the electron, but with the condition that last orbit will contain maximum of 8 electrons. This theory we can summarize as follow. First is the atomic number of atom is the number of proton present in the nucleus. The atomic number of krypton is 36. So, the number of proton in the nucleus part will be 36, and number of electrons equals to number of protons. So, 36 is the number of protons and 36 is the number of electrons. If you count these electrons, then that will come out to be a 36. 2 in the second or first orbit, 8 in second orbit, 18 in third orbit, and 8 is in the fourth orbit. So, if you add 2 plus 8 plus 18 plus 8, then it will come out to be 36. The algebraic sum of protons and neutrons of an atom is called the atomic weight or mass of the atoms. The number of proton inside the nucleus is equal to the number of electron outside of it. The electron on various energy level are arranged in definite shell named as K, L, M, N, and so on. So, first shell can be named as K, second shell can be named as shell L, and third orbit can be named as M shell or orbit, and fourth orbit can be named as N orbit or N shell. You can say either shell or orbit, both are same things. The outermost orbit of an atom can contain maximum of 8 electrons. So, atomic theory state that the number of electron in an orbit is follow 2n square formula, but with the condition that the outermost orbit of an atom can contain maximum of 8 electrons. So, back to the atomic structure of conductor. Now, you can understand that this is the nucleus containing the proton and neutrons, and this is first orbit, this is second orbit, third and fourth orbit. The atomic structure of good conductor usually include only one electron in their outer shell. It is called valence electron. It is easily stripped from the atoms, producing current flow. So, we already defined the definition of conducting material, which state that conducting materials are those material which allow the electric current to pass easily through it. So, this valence electrons allow the this valence electron can be easily freed from this atom, can be used as a free electron for the current conductions. If we take the example of copper atoms has atomic number 29. So, number of protons will be 29, and as we know that number of electron is equals to number of protons. So, the number of electrons in this atom will be 29, and the division of electrons in the orbit follow the formula 2n square. That means, in the first orbit number of electron will be 2, in the second orbit number of electron will be 8, in third orbit number of electron will be 18, and in the last orbit the remainder electron 2 plus 8 plus 18, 10 plus 28, remainder is 1. So, in the last orbit number of electron will be 1, 2, 8, 10 plus 18, 28 plus 1, 29. So, the last orbit or last shell is known as valence orbit, and the electron in the last orbit is known as valence electron. Valence electron can be easily freed from the atoms. We can use this valence electron, we can detach this valence electron easily by supply some energy, and can be used as free electron for the current conductions. So, when electron will freed from this atom, then only this single valence electron will freed from these atoms. Second is insulating material. Student, first is conducting material, second is insulating material. Insulating materials are those material whose do not allow the passage of electrical current, or we can say that material which offer very high resistivity to electric current is called insulating material. So, insulating material are those material which do not allow the electric current to flow through them. Conducting materials allow the current, insulating material do not allow the electric current to pass through it. The resistivity of these material is very high, and value is 10 raised to 12 to 10 raised to 18 ohm meter. The most well known insulating material are rubber, wood, glass, ceramic, mica, etc. Most insulators are compound of several elements. The atoms are tightly bound to one another, so electrons are difficult to strip away from the current flow. If we take the example of neon insulator, you can see in this diagram the atomic number of neon is 10 and number of electron will be 10, if we see that in first orbit number of electron is 2, number of electron second electron orbit is 8, so 2 plus 8. Now valence orbit is second orbit. This orbit is completely filled with the electron. It has no valency in this valence orbit. So there no electron is valence, or you can say no electron can be detached from this neon atom. So current conduction is not easy in the insulating material. Next is semiconducting material. The semiconductor material is a topic of our today's lecture. The semiconductor material are those material whose resistivity is less than insulator but more than conductor. In other words, we can say that conductivity of these material is less than conductor but more than insulator. The resistivity of these material is medium. Its values lies between 10 raised to 0 to 10 raised to 2 ohm meter. The most well known insulating materials silicon, germanium, gallium, etc. So semiconductor materials are not a conducting material and neither a conducting material nor a insulating material. The value of resistivity of semiconducting material lies between conductor and insulating material. So you can also say that semiconducting material are conducting material as well as insulating material. In one condition they act like a insulating material, in another temperature condition they act like a conducting material. The main characteristics of semiconductor element is that it has 4 electron in its outer or valence orbit. If look at the atomic structure of silicon semiconductor material, the valence electron, the atomic number of silicon semiconductor material is 14. So if we divide the electrons in different orbit, in first orbit usual number of electron will be 2, in second orbit number of electron will be 8, and in the third orbit number of electron will be 4. The remainder electrons 2, 8, 10 plus 4, 14. 14 are the number of electron in the silicon semiconductor. These 4 electrons are valence electrons, and the vacancy in the valence orbit is of 4 electrons to complete the outermost shell. So almost all the semiconductor material has the 4 valence electron, because these 4 valence electron will form the covalent bonding with the neighboring atoms. Next is magnetic material. The magnetic materials are those materials which can be magnetized and which are attracted towards the magnets. Such material creates a magnetic field on surrounding space. Iron, nickel and cobalt are most well known used magnetic material. So magnetic material ਉਹ ਵਾਲੇ material ਹੁੰਦੇ ਨੇ ਜਿਨ੍ਹਾਂ ਨੂੰ ਆਪਾਂ ਮੈਗਨੀਟਾਈਜ਼ ਕਰ ਸਕਦੇ ਹਾਂ, ਜਾਂ ਉਹ ਵਾਲੇ material ਜਿਹੜੇ ਕਿ ਮੈਗਨੇਟ ਵੱਲ ਅਟਰੈਕਟ ਹੁੰਦੇ ਹਨ. Next is semiconductor material. As you know, semiconductor material are those which possess the conductivity higher than insulator but lesser than the conductor, and are used for manufacturing of most of the active component. So again we will discuss the atomic theory. As already I discussed this topic, atomic theory, that all the matter, whether solid, liquid or gases, consist of minute particles called molecules, which can be further divided into atoms. Atoms are tiny particles which are incapable of divisions. Bohr atomic theory, again it consists of 2 main parts, nucleus and extra nucleus. The center part is called nucleus and outer part is called extranucleus part. In the center part, proton and neutrons are there, and in the extranucleus part, electrons revolves around the nucleus in a definite orbits. So, number of electrons in the orbit is follow the formula 2n square, n is the number of orbit from nucleus. So, in the first orbit, number of electron is 2 1 square 2 electrons. In second orbit, number of electron is 2 2 square 8 electrons. In third orbit, number of electron is 2 3 square 18 electrons. And we are this follow the formula 2n square. N is the number of orbit. Bohr atomic theory summarization we have discussed already. Next is classification of material on the basis of atomic structure. On the basis of atomic structure, conductor is defined as substance whose atom has its outermost orbit incomplete. Such a substance acts as good conductor of an electricity. For example, aluminium or conductor. So, on the basis of atomic structure, we are classifying the material. First is conducting material copper. It is denoted by Cu. Copper is denoted by the symbol Cu. It has atomic number 29. Atomic number of copper is 29, and atomic weight of copper is 64. So, first formula is number of electron in atoms equals to number of protons in an atoms. जिन्ने number of protons होंगे किसी भी atom दे विच उन्ने ही number of electrons होंगे. So, all the atoms are electrically neutrals. Second is number of electrons equals to atomic number. जिन्ना किसी भी atoms ਦਾ material ਦਾ atomic number होगा उन्ने ही उसदे विच number of protons ਤੇ number of electrons होंगे. So, atomic number of copper is 29. So, number of protons in the nucleus is 29, and number of electron in extra nucleus will be 29. Number of neutron equals to atomic weight minus atomic number. Atomic weight is 64, atomic number is 29. So, number of neutron in the nucleus part will be 35. Atomic weight minus atomic number, 64 minus 29. 35 will be the number of neutrons present in the nucleus part. Neutrons are electrically neutral. Protons are proton has positive charge and electron has negative charge. So, number of electron in K shell of copper atom is 2 1 square, follow the formula 2n square. N is the number of orbit from the nucleus. So, in the first orbit, in the first shell, or you can say in the K shell is the first shell, the number of electron will be 2, that is 2 1 square equals to 2, and number of orbit in second shell, or you can say in L shell or orbit, is 2 square equals to 8. So, number of electrons in second orbit or L shell is 8. You can count 1 2 3 4 5 6 7 8. 8 electrons present in the L shell. In the M shell, the number of electrons is equals to 2 3 square equals to 18. You can count the number of electron in third orbit will be 18. In the last orbit, the condition is in the last orbit maximum number of electron will be 8, but in this case the remainder is 2 8 10 plus 28, the remainder is 1. So, in the last orbit number of electron will be 1, and this last orbit is called valence orbit, and electron present in this last orbit is called valence electron, which can be easily detached from the nucleus. These all the electrons are held by the force of nucleus. So, this last electron is loosely attached to the nucleus and can be easily detached from the this atom. So, there is one electron valence on it, it is called free electron or valence electron. Valence electron of an atom are defined as the electron which are loosely attached to the nucleus at an atom and can be easily detached. So, this electron, last electron, can be easily detached, and this electron will responsible for the current conductions, this last electron. Next is orbit, next is aluminum. It is denoted by Al, capital A, small l, having atomic number 13, atomic weight 27. So, number of electron will be equals to 13, that is atomic number of aluminum, and number of proton equals to 13, that is the number of electron equals to 13. Hence, number of electron 13. Number of neutron is atomic weight 27 minus atomic number 27 minus 13 equals to 14. So, number of neutrons in this aluminum atom is 14. Number of proton is 13, number of neutron is 14, and number of electron is 13. So, again in K shell, that is in the first shell, formula 2n square, n is 1, 2 1 square equals to 2, and number of electron is 2. In L shell, that is in second shell, formula is 2n square, n is 2, 2 2 square equals to 8. In second shell, that is in L shell, number of electron is 8, 1 2 3 4 5 6 7 8. In third shell, that is in last shell, number of electron will be, the condition is maximum of 8 electron, but the remainder is 3, 2 8 10 plus 3 equals to 13. So, in the last orbit, that is in the M shell, number of electron is 3, and these 3 electron is called valence electron, and these can be easily detached from the nucleus. So, there is 3 electron valence on it, it is called free electrons. Valence electron of an atoms are defined as the electron which are loosely attached to the nucleus at an atoms can be easily detached. Classification of material on the basis of atomic structure. Next is semiconductor material. In semiconductor material, if a potential difference is applied across the end of material, a partial flow of electron takes place, that is, some of electron can be detached from the atoms and some of them cannot be detached. Hence, the conduction is partial, and therefore, the property of semiconductor are in between those of conductor and insulator. First semiconductor is silicon. It is denoted by capital S, small I, Si, having atomic number 14 and atomic weight 28. So, again center part is nucleus. In first orbit, number of electron will be 2, in second orbit number of electron will be 8, and in the last orbit the remainder 2 8 10, remainder is 4, 10 plus 4 14. So, in the last, that is in M shell, number of electron will be 4. So, there is 4 valence electron in its outermost orbit. Germanium. Germanium is denoted by Ge and having atomic number 32, atomic weight 73. Number of electron in first shell will be 2, in second shell, that is L shell, will be 8, in M shell 18, and in last shell 2 plus 8 10, 10 plus 18 28, and remainder is 4. So, same way the number of valence electron in last orbit in germanium semiconductor atom is 4. Next is insulator. The atomic number in insulating material, the electrons are firmly held to their atom, and hence if potential difference is applied,